Here we are in the mid-chapter 2 review exercises with the solutions to numbers 27 through 32. We're doing absolute value inequalities, and notice that we need to solve and graph them and write the answer in set and interval notation. All right, starting with number 27. 27, here we have, oh look, absolute value of 3x plus 5 is less than or equal to a negative number. That means something special is going to happen. If this guy is positive, just remember absolute values always make a positive number. Is that ever less than or equal to a negative 5? No. So number 27, that will be no solution. We don't even have to do any work for that one. All right, number 28. Here we have absolute value of negative 7x plus 6 is less than 18. Absolute value is less than something. When the distance is constrained by a number, is smaller than a number, then it is an AND statement because it must stay in there and cannot shoot off to infinity. So negative 7x plus 6 less than 18, bigger than a negative 18. And this is an AND statement, so we can write it as a compound inequality. Notice that the negative one has this sign switched. It looks like it's going the same direction, but the negative 7x plus 6 is on the bigger side of the inequality. So subtract 6 from all three places, and we get negative 24 less than negative 7x less than 12. Divide by the negative 7, and what happens when we divide by a negative number? The inequalities must switch directions. So this is 24/7 greater than x greater than negative 12/7. If we don't switch the signs by that negative sign, we will have negative 12/7 bigger than 24/7, which doesn't make any sense at all. So put the little special x such that with the braces here, and we have set notation. Let's graph these. There's 24/7 will be about right up there. 24/7, that's about 3 3/7. And then negative 12/7 be down here, negative 12/7. And we are in between those two. And do we cover and hit the endpoints? We do not. So that is with parentheses. So there's the graph. There's set and interval notation will go from negative 12/7 up to 24/7. And open on both ends. Good. Number 29, 3x minus 5 in absolute values greater than or equal to 12. This is an OR statement. We can have this stuff bigger than 12 or smaller than negative 12 to work. So this is going to be 3x minus 5 greater than or equal to 12, or 3x minus 5 less than or equal to negative 12. And there's an OR in between them. So solve this guy, add 5, 3x less than or equal to negative 7, divide by 3, and we get x less than or equal to negative 7/3. Or add 5 and we get 3x greater than or equal to 17, divide by 3 and we get x greater than or equal to 17/3. Put our nice little notation here, and that is set notation as a solution. Graph down here, we are negative 7/3. There, and we're smaller than that with an inclusion of that endpoint. And then 17/3 is up here somewhere. Looks like about 5.666, something like that. Interval notation then goes from negative infinity up to negative 7/3. Including negative 7/3, we never hit negative infinity. Union, that's equivalent to the OR statement, to 17/3 to infinity. Number 30, here we have absolute value of 4 minus 7t greater than or equal to negative 3. This negative is an unusual experience here. Let's replace this. We know that absolute values are always positive. Is a positive number ever bigger than negative 3? Yes, it always is. So we're going to get x as all numbers. Or if in set notation, you would just write the set of all real numbers. Graph looks like this. Hey, look, that's everything going both ways, and it is negative infinity to infinity, and we didn't even need to do any work to figure that out. Absolute value will turn anything we stick in here positive, which will be bigger than or equal to negative 3. Never equal to negative 3, but definitely bigger than. All right, number 31. Here we have 3 minus 6r greater than 10. 3 minus 6r less than negative 10. Notice our absolute value is greater than something, so it will be an OR statement. So we solve this, subtract 3 from both sides, we get negative 6r less than negative 13. Divide by a negative 6, divide by a negative 6. What happens when we divide by a negative? R is greater than 13/6. Over here, subtract 3 from both sides, we get negative 6r is greater than 7. Divide by a negative 6, and we get that r is less than negative 7/6. So that would be, if there's negative 7/6 right there, we are less than, it's going this way with not including, so that's a parentheses there. And then 13/6 would be up here, and we're going to go this way with it. Great, so the set notation will look like this with an or in the middle. Interval notation will say negative infinity down up to negative 7/6, not including it, never hitting infinity, or that's the symbol meaning union, and then 13/6 all the way up to infinity. Excellent. And the last one, number 32. We have 18m minus 9 is less than negative 6. We have a negative number over here. Something special is going on. So let's look at this guy. Absolute value always comes out positive. Is positive ever less than negative 6? It is not. This is a no solution, and we don't need to do any work. And it will not have our graph. Alrighty, there you go.